Hello students, this is a short video in which we're going to look at the sum and difference identities for cosine, sine, and for tangent. I'm just going to show you in this video how to use each of the formulas, and then in class we'll talk in more detail about some of the background information. In the past, before we had a lot of access to computers and calculators, if we wanted to know one of the trig values for an angle that is not on the unit circle, we would have to use a combination of other angles that we knew. For example, suppose that I wanted to figure out the cosine of 15 degrees. 15 degrees is not one of the angles on the unit circle. But what I could do instead is think about two angles that I know on the unit circle, 45 degrees minus 30 degrees. That would get me to the 15 degrees. Using this second version of the equation, I'm going to use A as 45 degrees. That'll be the first angle. And then B will be 30 degrees. So wherever I see A in this formula, I'll put 45 degrees, and wherever I see B, I'll put 30 degrees. So we'll have cosine of 45 degrees multiplied by cosine of 30 degrees. That's the first part of the formula. And then that's this part here. And then we'll add the sine of 45 degrees times the sine of 30 degrees. That's the second part of the formula here. Now what I do is I think about the values that I know for each of these. I know that the cosine of 45 degrees is square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 6. Square root of 3 over 2. The sine of 45 degrees is square root 2 over 2. And the sine of 30 degrees is 1/2. Now I'll multiply these fractions straight across. When you have two square roots that are being multiplied, you can combine the two numbers together under the radical symbol. And so I'm just going to end up with square root of 6 there. So square root 6 over 4 plus square root 2 over 4. I could combine this into one fraction if I want, because the denominators are the same, and this will be my final answer. If you are using the TI-36X Pro, it will give you this exact answer, and there are other calculators online that will give you this exact answer as well. So that's why I'm sort of glossing over this section a little bit, but we just need to know that these formulas exist. For this next example, we're looking at radians instead of degrees. And when we think about radians, we have to kind of reason through what are the different angle measurements that we could add or subtract together to get to, in this case, 5 pi over 12. So what I'm going to do is I'm going to write all of the values that are on the unit circle in terms of twelfths. So here at 0, this would be 0 pi over 12, obviously. Normally, we would call this pi over 6, but another way to think of that is 2 pi over 12. This is pi over 4. We could rewrite that as 3 pi over 12. Pi over 3 can be written as 4 pi over 12. This is pi over 2. That's 6 pi over 12. I'm just rewriting everything with that common denominator of 12 and so on. And so looking at this example here, it looks like they took this value and this value and added them together. If they take pi over 6 and pi over 4, the rewrite of that is, let's say, pi over 6 plus pi over 4. When we write this with a common denominator, that's 2 pi over 12 and 3 pi over 12. That's where we're getting that 5 pi over 12. And then we plug into the formula. In this case, it's the sum formula for cosine. And then we just extract the different values. The cosine of pi over 6 is root 3 over 2. The cosine of pi over 4 is root 2 over 2, and so forth. And just like we did in the last example, we multiply across to get square root of 6 minus square root of 2, all over 4. I think the most challenging part of doing these problems is figuring out what two angles you can combine together to get to the desired angle. We also have formulas for the sine and for the tangent. You will find all of these formulas in the formula sheet that I have posted on Canvas. And these next set of examples are just using these different formulas, but following the same process that we did for the cosine. If we want to find the sine of 75 degrees, it looks like we can take 45 degrees and 30 degrees and add them together. This is plugging just the different components into the formula and then extracting the values from the unit circle. This is the sine of 45 degrees. This is the sine of 30 degrees, and so on. And then multiplying across to get a final answer. Again, you can go to your calculator and you can type in sine of 75 degrees, and it'll give you this answer of root 6 plus root 2 over 4. Now, Desmos will give you a decimal answer, but there are other calculators online that are specific to trigonometry. You can Google a trigonometry calculator for exact values. Exact value is not going to be a decimal, and you can get these answers. For 7 pi over 12, it looks like they're adding pi over 3 and pi over 4. Let's look at that for a second. Pi over 3 plus pi over 4. Rewriting these to both have a denominator of 12. We have 4 pi over 12 and 3 pi over 12. And yeah, that adds to be 7 pi over 12. What they've done right here is they've plugged in those angles into the formula and then extracted the values from, you don't have all the tangent values on the unit circle, but we have to think about what's the sine over the cosine, or you could use a calculator here. So tangent of pi over 3 is this value. Tangent of pi over 4 is this value. And then we have 1 minus, and we multiply those two items together. Now, what we end up with, I'm going to, let's look, this simplifies to this part right here. Okay? But technically, we're not supposed to leave a square root in the denominator. So what they've done is they've multiplied by the conjugate. The conjugate comes from, we're not supposed to leave a square root in the denominator, so we look at what's given to us in the denominator. We write the exact same item, we just change the sign in the middle from negative to positive, or vice versa. And then we multiply that out to get this. Let's do the side work here. I'm going to look at, first, let's look at the numerator. They have square root of 3 plus 1, and 1 plus the square root of 3. I'm multiplying this out. First, I'm going to multiply these together. Then I'm going to multiply these together. Square root of 3 times the square root of 3 is just going to be 3. Then I'll multiply these together. And then I'll multiply these together. I'm just using the distributive property or FOIL, however you want to think about it. It looks like I've got 2 square roots of 3 here. Right, I've got 1 here and 1 here. So 4 plus 2 square root 3. That's what they're ending up with right here. That's the numerator. Let's look at the denominator next. For the denominator, and the reason we choose the conjugates is because if we do them correctly, those square roots should go away. So I have 1 minus the square root of 3 multiplied by 1 plus the square root of 3. Again, let's use the distributive property or FOIL. We have 1 Then we'll multiply this to get square root 3. Then we'll multiply this to get minus square root 3. And then we multiply this. Notice it's a minus multiplied by a plus. So we're going to have minus 3. Square root of 3 times the square root of 3 is square root 9, which is the same as 3. Okay, so these two are going to cancel each other. And I just have 1 minus 3, which is negative 2. That's what they've got down here in the denominator. And then the final step is to divide out that denominator into both the numerator, both terms in the numerator. 4 plus 2 square root 3 over negative 2. We can split that into 4 over negative 2 plus 2 root 3 over negative 2. So we're getting a negative 2 for the first term, and then a negative square root of 3 for the second term. Again, this is the algebra behind how we get these answers. If you plug this into your calculator, some calculators will give you these, some, it depends on what trig function you're plugging in. Sometimes tangent, it doesn't always give you the answers, but sine and cosine, it definitely will give the answers. And then this last example is just having us verify an identity. It turns out that an identity is something that's going to be true for any angle that we're plugging in. So we're going to prove that for any angle that we plug in here, for theta, right, that putting these two things together, we're going to simplify the whole thing to be cosine theta. So I'm going to start with what I have on the left-hand side here. And then this is going to be the formula for sine of two angles added together. And then this is going to be the formula for cosine of two angles added together. Now we don't know what theta is, but what we can do is plug in what we know for sine of pi over 6 is 1/2. Cosine of pi over 6 is square root 3 over 2. Cosine of pi over 3 is 1/2. And sine of pi over 3 is root 3 over 2. Now we're going to combine things together. Look at this. This is square root of 3 over 2 times sine theta, and this is negative square root of 3 times sine theta. Those two are going to cancel each other and be gone. And so we're just left with two sets of 1/2 cosine theta, and we add those together to get 1. So this identity is proved. We're not going to focus too much on these types of problems in class, but it's just giving you an idea of how we can use these sum and difference identities. All right, thank you for watching, and I will see you in class.